Hey everyone, welcome to the Trent Elementary School Science Lab. I'm Mr. Junta, and we're going to do 6 experiments in 6 minutes. In kindergarten, during our third rotation, we are working on finding engineering principles from fairy tales. So this is the Steadfast Tin Soldier, and you can see he is on a paper boat. So I'm wondering, what sort of materials do we have around our house that can float, and what materials would sink if we wanted to try to build him a boat at home? And this is a cool project you can just do in a sink or in the tub at home. I've got paper, looks like it floats. We've got a wooden craft stick, looks like it floats. We've got pipe cleaners. I did it in a circle. You could do all sorts of shapes. Looks like it sank. We have a metal spoon, sinks, sponges, float. Uh-oh, and our paper's taking on water now too. I don't know if it's going to stay afloat. You could try other materials you have around your house. I've got other spoons and styrofoam. Some of those are floating too. All right, in first grade, your students have been collecting weather data to look for patterns with their teachers. We have a weather collecting computer on the top of the science lab. Just go to trentsciencelab.org and click on today's weather, and you can see what you're looking at. But you can make your own rain gauge at home to see how much water you just had after a rainstorm. So all you need is a water bottle that you finished using. You'll cut the top off. So you have just the funnel of the top left over. Invert that and put it back in your water bottle. Tape it on nice and good. Add a few rocks in the bottom and a little bit of water, just enough to cover the rocks. When you do that, add one more piece of tape where the water starts, and leave this outside before a rainstorm, and wherever is added onto your water there, however high up it goes, is how much rain you just had. Easy project to do at home. All right, next we have the states of matter with second grade, and this is definitely a project that you want to get a grown-up to help you with. I have some frozen ice pops here, and I love these because you can see how much water is in them and how much has melted and turned into liquid and how much is still a solid or frozen. So we're going to go ahead and take the top off of this. Strawberry flavor. Sorry to waste you, buddy. We have our solid frozen water in here. We're going to add it to our pot, and we're going to see pretty quickly that it's turning into a liquid. So we have melted ice pop. I'm going to come right back to that in just a second. Got chairs everywhere, guys. There's not even anybody sitting in them. Okay, in third grade, we're looking at soil, rocks, erosion. We're going to start off with investigating minerals. I have quite the mineral collection, thanks to the Trent Tiger Foundation. And if I wanted to pick one of these to try to determine its properties, like this little guy, I can look at its color, its shape, its luster, its texture, the way it feels. But I can also do a hardness test. And I can try scratching it with my fingernail. That doesn't do anything. I can try scratching it with a penny. Nothing happening there. Even a nail. No luck. And then finally, I could use something like a streak plate to try to scratch it. And that one's going to leave little teeny scratches on my mineral. Using all that information and downloading my rock and mineral log from Mr. Junta's CTLS page, you can figure out what mineral you're looking at. All right, we've got some boiling action happening here. And our ice pop, ooh, yeah, you can see the steam coming up. Our ice pop is turning into a gas, so it's becoming water vapor or steam. Let's turn that off so we don't burn down the science lab. Okay, speaking of burning things down, it has been so nice out lately. I haven't missed the summer temperatures, but it got me thinking for our fourth graders, what is causing the seasonal change? I love the change of seasons. So here's our globe. It's sitting straight up and down with the North Pole facing up, but that's not how it is in outer space. It's tilted at its axis 23.5 degrees. Well, what's causing it to get warm and cold in the summer and winter? Here we have our thermometers, and they're at 70-something degrees, 72 degrees. going to add one to the Arctic Circle and one to the Atlanta. I'm going to plug in our sun. And we're going to let those heat up. While they're heating up, let's go over to 5th grade. And in 5th grade, we're doing tectonic plates. I've made some magic matter, or some kinetic sand, out of 4 parts play sand, 2 parts cornstarch, and 1 part water. And by mixing those materials together, I can create convergent plates where 2 plates meet and cause mountains. I can do divergent plates where they spread out, causing a rift or a valley in the land, and magma would come up if these were a little more melty. Or I can do transform plates where they're sliding past each other and causing violent earthquakes. We can also cause volcanoes if one moves up over the other. The one underneath melts and new land comes up. All right, let's go check on our seasons. 3 seconds. Oh no. We have direct sunlight hitting the equator here, or just above the equator, and we're already at 80 degrees. And up here where there's indirect sunlight, we're still at just 72 degrees. So the big difference there with our seasons is not where we are at in space. Oh gosh. Whew, that's loud. Not where we're at in space, but how much light is hitting us and at what kind of angle. Okay, that was 6 experiments in 6 minutes and 30 seconds, guys. I can't wait to see y'all soon.